All right, let's look at another method where you don't have a common GCF. So my first instinct would be to pull out a 4. However, I can't do that because 21 can't be divided by 4. So again, this is going to be a problem with the A times C method. So I'm going to multiply my A term, which is 4, and I'm going to multiply it by my C term, which is negative 21. Four times negative 21 is negative 84. So I got to think of what will multiply to negative 84 but add to 8. Since I'm multiplying to a negative number, I know I'm going to want one of my factors to be negative. But first, let's just think of some numbers that will multiply to 84. I could divide 84 by 2, 2 and 42. But those numbers are really far apart, and it doesn't look like it's going to give me 8 right away. Let's try to think of something bigger. As I was thinking about 84 divided by 12, I had 12 and 7, which these numbers aren't too far apart. So, for instance, if I take 12 minus 7, that's 5. It's kind of getting close to 8. So I try to think about, what about 84 divided by 6 instead of 7? That was 6 and 14. 14 minus 6 is 8, so these are going to be our factors. Now, it needs to multiply to a negative, but add to a positive. So since it's multiplying to a negative, one factor must be negative, but since it has to sum to a positive number, the larger number must be positive. So it's going to be negative 6 and 14. So I'm going to rewrite my sum, 4x squared minus 6x plus 14x minus 21. Now from there, I'm going to make sure that the terms I wrote next to each other have common factors. So one thing I want to point out is this. So at any time, if I wrote these two factors and they were swapped, and let's say they didn't have common factors, you can switch the order. So it doesn't matter the order that you write the negative 6x and the 14x. Just make sure that they're written next to something that will have a common factor to pull out. And make sure that they're written next to something that will have a common factor to pull out. If there isn't a common factor to pull out, try swapping the order of these two middle terms. So I can definitely pull out an x from these. And more important than an x, 2 can go into both. So 2x times 2x will be 4x squared. And what I'm missing here is a minus 3. From both of these, I can pull out a 7. If I pull out a 7, I need a 2x. And here I need a minus 3. All right? You can FOIL it back to check. 2x times 2x will be 4x squared. 2x times negative 3 will be negative 6x. 7 times 2x will be 14x. 7 times negative 3 will be negative 21. Since this is repeated, we know we did it correctly. So our final answer is going to be 2x plus 7, 2x minus 3. Now this is not a trinomial, primarily because tri means 3 and we only have 2 terms here. This is what we're going to call a difference of perfect squares. Difference means subtraction. Squares are something that you can take the square root of and get a whole number. So importantly, to be a square, it has to be a number times itself. So for instance, 2 times 2 gives you 4, so the square root of 4 is 2. 8 times 8 is 64, so the square root of 64 is 8. If you could take the square root of every term and you have subtraction, that would be how you know it is a difference of squares. Now the way a difference of squares works is you have 2 sets of parentheses, one that has a plus and one that has a minus. And this is always the format for a difference of squares. So I'm going to take the square root of 4, which is 2. I'm going to take the square root of x squared, which is x. I'm going to take the square root of 9, which is 3. And that's it for a difference of squares. It's just that straightforward. Let's try one more difference of squares. Now, this looks like a difference of squares right off the bat. And it is, but the important thing that you want to do first is check and see if there is a greatest common factor. Every time you approach a factoring problem, you first want to see if there's a greatest common factor. In the previous question, 4 and 9, they had no common factor That's why I could go straight to a difference of squares. But with 104, there's something in common, so I definitely want to pull that out first. All right? What number can go into both 100 and 4? So it should be clear that 4 will go in. So I can pull out 4. 4 times 25 will give me the 100. I still need the m squared, and this is minus 1. Don't be alarmed. 1 is actually a number that you can take the square root of, because 1 times 1 is 1. So I'm going to keep the 4 on the outside. The square root of 25 is 5. The square root of m squared is m. The square root of 1 is 1. Remember, you always need another pair that just has the opposite sign. And this would be your final answer. Thank you for watching. I hope factoring is getting a little bit better. We're going to do more practice problems in our next video.